Year 10, today we're going to look at finding specific equations of straight lines. So we did this really early on in the year, so it's not surprising you've forgotten little bits about it. I'm pleased to see that you remember what the gradient of a parallel line is, and I hope the gradient of a perpendicular line. But we're going to look at what we do when we're given a specific point that the line goes through. So we're finding an equation of a line parallel to y equals 2x plus 6. Now the first thing is that it's already in the form y equals mx plus c, so we're just going to leave it like that. If it was in a different form, we would rearrange it into y equals mx plus c. Now, because the line is parallel, we know that the gradient of the new line is also going to be the same as this line. So my gradient is going to be this here, so my gradient is 2. I know my gradient's 2, so I can put it into my general equation, y is equal to 2x. And now here's the important thing, I have to put plus c, because I don't know what part of the y-axis this line goes through. I just know that it's parallel to this line here. It could go through the point 1, it could go through the point 2. Remember, this part tells us the y-intercept. We do know that it passes through the point 2,5, and we're going to use this to find our value of c, because we know an x-coordinate and we know a y-coordinate, so we can find the other unknown. So I'm going to substitute x is equal to 2 and y is equal to 5. Put it into this equation here, so I know that 5 is equal to 2 multiplied by 2 plus c. Can evaluate this, 5 is equal to 4 plus c, and then if I rearrange, I can see c is equal to 1. Once I've got my value of c, I put this back into my equation, so y is equal to 2x plus 1. And this is the equation that's parallel to this line because it has a gradient of 2, and it also goes through this point here because both of these points go into this equation. Now I thought we'd look at an example where we're looking at a perpendicular line as well, just to make sure we know what we're doing with this. The first thing you'll notice is that we have the equation in the form y plus 2x minus 3 is equal to 0. So we want to rearrange this to put it in the form y equals mx plus c. So we have y is equal to minus 2x, because I'm taking that over to the other side, plus 3. Perpendicular lines have negative reciprocal gradients, so the gradient is going to be the negative reciprocal of minus 2, which is positive 1/2. I can rewrite this in my general form, so y is equal to 1/2x plus c. And I do exactly the same thing as with the parallel line. So I've got the point 1, 3, and I'm going to substitute this into my equation. So x equals 1 and y is equal to 3. 3 is equal to 1/2 multiplied by 1 plus c. And then I'm going to rearrange for my value of c. So I have c is equal to 2.5, or you can leave it as a fraction if you want. Once I have my value of c, I'm going to put it back in. So y is equal to 1/2x plus 5/2. And this is my perpendicular line that goes through the point 1, 3.